My name is Ahmet Eren Üçel, and now I will present you my EEE 102 Digital Logic Design Term project, which is about an adaptive light system and a control feedback mechanism. For this purpose, I wanted to also decorate and make a real-life application with a lighthouse and a military range. For this project, I will be using three external components. The first one is PIR motion sensor, HC-SR501. The second external component is the 7-segment display, on which I will show the percentage brightness of the LED on top of the lighthouse. And finally, I will be using a finite state machine in my code to transition between two states, which is idle when there is no motion, and the second one is active when there is motion. So I can show the demonstration right now. Initially, I will be using the roughly 25% of brightness, LED brightness, which I generated with a PWM. When PWM is 256 over 1024, which is the result of using a 10-bit counter, we will be giving 25% of LED brightness, which is the default value when there is no motion. The state is idle, and our input is motion, so I can show you how it changes with this way. Right now it is 25%, and I will move my hand before the sensor, and the brightness increased up to 79%, which is roughly 80%. Right now I can also show it on the LED, and as you can see, there is a significant change, and it will go to zero, motion zero, with a time delay of 3 seconds, which is a use of this motion sensor. And we also have a manual mode of this project, which I will be changing with this switch. Right now, I just left it at the final part. I left it at 98%. I will be using these buttons to decrease it. For example, it is decreasing by a significant portion. Let me change it. Let me show it up to 0, down to 0 actually. So we'll make it 0. The reason that it decreases by 1 is that I designed the counter that way. Right now it is 0%, which is complete dimness, and as you can see, the LED is at complete dimness. And when I increase it up to 70%, there will be a significant change in the LED brightness, and after 70%, the 7-segment display will give a warning with letters H and I to show that there is high LED brightness, which in real life we can think of as a ship moving through. In the manual mode, regardless of any motion in front of the motion sensor, there will be no change. However, when we change it to the auto mode, when we make a change, the LED brightness will also increase up to 79%. And we made use of this sensor in terms of 3 sensitivity cases. The first one is about time delay, in which right now we are using the smallest one, which is 3 seconds. We also have a range delay, which is from 3 meters to 7 meters. However, as we make use of a very little portion of the range, there is no need for that much change in that. And then finally, we have a repeatable trigger model and single trigger model. We use repeatable one to change from 0 to 1, to transition between states continuously. So that's all about my final project.